Okay, so I'm now going to do question one, okay, the in-class exercises question one, just to refresh your memory on the reasons for error term to exist. So Ronel wants to examine the impact of years of working for current employer tenure and years of work experience of monthly salary. Okay. But unfortunately, it is extremely difficult for the respondents to remember the exact years of work experience. So she decided to approximate the work experience as by deriving xxx, which is equal to age in years minus years of education minus 6. Okay, you might wonder how would this proxy variable looks like that. The reason is we assume that the person starts schooling at 6 years old, and then after spending whatever number of years in education, okay, then the person will start working. So you can think of an example. If the person is 20 years, so age is 20, and the person stops schooling after matric, so 12 years old, then wouldn't the estimated or proxy years of work experience would be 20 years minus 12 years at school minus 6 years. 6 years of childhood, remember, the person only starts schooling at 6 years old. Then we approximate the person's year of work experience is 2 years. Remember, the person matriculated at 18 years old, then we have to assume the person immediately could find work actually after matriculating. Then if the person is 20 years old, then we assume the person works has 2 years of work experience. Okay, but this is actually, you already can kind of realize there will be some noise or inaccuracy in this proxy variable. And then we run the multivariate regression. Salary is equal to tenure, years of working for the present employer, and XXX, the proxy of years of work experience. And then there are 7 reasons for the error term to exist, which means difference between the actual Y and expected Y. First reason is vagueness of the theory, lack of understanding of the theory, because Ronel is not aware of other explanatory variables. So she doesn't fully understand the theory, and she doesn't realize other relevant explanatory variables also have an influence on salary. So she committed underfitting actually. Okay. For example, productivity has an impact on wage, even race and gender because of discrimination. Okay. Like let's say gender discrimination, race discrimination, even occupation. If you work in highly skilled occupation, you should earn more. Even age, it is argued elderly people should earn a bit more because of their comprehensive experience. Unavailability, because we wish we could include an explanatory variable, but the data is not available, so we reluctantly exclude it. For example, we do not include productivity in the regression because it is difficult to measure or capture data on productivity. So I have an example. How do you measure productivity of teachers? Based on what? Class size, pass rate, or attendance rate? So it is hard to, especially in the services sector, maybe manufacturing, it is easier, much easier to capture productivity, which is output over input. But for services industry like teachers, hotel industry, and so forth, it is much more difficult to capture and quantify information on productivity. Therefore, we reluctantly exclude productivity. Then we end up creating some discrepancy between actual Y and expected Y. Then that explains the presence of error terms. Third, we want to simplify. Third and fourth, it's about reasons. It's about simplifying the regression. Core explanatory variables versus peripheral explanatory variables. Because remember, when we want to capture information or data on explanatory variables, it's quite time consuming and costly. So we don't want to waste time and cost to capture information on some minor or peripheral explanatory variables that would only have a minor or relatively less important influence on salary. For example, maybe the time you spend on Facebook during work hours could have some impact on your wage. It implies laziness, but again, it might only have a minor influence. And again, it is hard to capture data, quantify data on time spent on Facebook, unless you install CCTV on the worker's office location. Principle of parsimony, we want to keep the regression as simple as possible. Imagine I run a regression with a list of 20 explanatory variables. It is hard to read the regression equation already, not to say to interpret the regression output. So in other words, we only want to include the strongest, let's say 4 or 5 explanatory variables. They have or we say core explanatory variables, so we can keep the regression model as simple as possible. Intrinsic randomness in human behavior, it means even if we If we run the most flawless regression, we include all the relevant explanatory variables, there is still bound to be some noise or intrinsic randomness in the individual Y or human behavior that we can't explain no matter how hard we try. For example, even if X2, the 10-year year, is the same for all the people, there will most likely still be some differences in their salary. I can't expect people with exactly the same 10 years work, let's say working for 2 years. For the current employer, they would all earn exactly the same salary. It is impossible. There's bound to be some discrepancy or differences. The sixth reason is the poor proxy variable, which is this one, the proxy of years of work experience. Okay, it is not 100% accurate. I think I already mentioned one assumption is that the person after leaving school can immediately find work. Will it really happen to everyone? And also for the female population, some will stop working for a while because of reasons like pregnancy, or they want to be full-time housewives, so they temporarily leave the labor market for a while. So there's already a lot of noise with this proxy XXX variable, the proxy of years of work experience. Then it would lead to difference between actual Y and estimated Y or expected Y, thereby leading to the presence of error terms. And finally, maybe you use the wrong functional form, that it would also lead to the presence of error terms. For example, we usually take log for the wage. Okay, so maybe we should run it as a log lean model, or yeah. Okay, there's actually a typo error. It should be like log lean model. Okay, or double log actually. Some would argue we should even take the log of years of tenure and so forth, years of log of years of work experience. Okay. Slide 20 to 29. Okay, different types of data. Okay, cross-sectional data, 4 types of data. Cross-sectional data means data collected on individuals who took part in a survey at a particular point in time, such as these 5 people, A, B, C, D, and E. They were interviewed in census 2011. So that's cross-sectional data. Time series data means data collected on some variables over a period of time, let's say from 1990 to 2019, annual data on real GDP, inflation, rand, dollar exchange rate in South Africa. If we pool at least 2 cross-sectional data together to combine it as an appended data set, then we call it pool cross-sectional data. So look at this as an example. These 5 people, A, B, C, D, and E, took part in census 2011. You can see at that time, quite a lot of them were unemployed. I just want to simplify things, that assuming there are only 5 people in total in census 2011. So most of them are unemployed. Most of them did not have mobile phone. And then in the 10 years later, in census 2021, persons F, G, H, I, and J took part. You can see different people took part, and then you see the improvement. Although it is a hypothetical example, more people were employed, 4 out of 5, and then everyone had mobile phone at the time of census 2021. So you can see the improvement in the labor market outcomes and non-income welfare in terms of ownership of mobile phone after 10 years. Okay, so this is pool cross-sectional data. Panel data, I wonder if you have heard of the National Income Dynamics Study, NIDS. It is the first South African panel data. Panel data means the same people were interviewed more than once. So let's look at this example. In 2008 NIDS, persons M and OPQ took part, and then you can see 4 out of 5 were unemployed, some had mobile phones, some did not. And then the same 5 people, so this is the difference between panel data and pool cross-sectional data. Pool cross-sectional data, you could have different people taking part in each survey. But panel data, you have the same people taking part in a survey more than once. So for this one, I assume 2 waves of needs. This is first wave, 2008, 2010, second wave. Okay, we can keep, the purpose of using panel data is to keep track of the income and non-income welfare of the same group of people over time. So if you look at this one, do you notice that M and N, they got stuck in unemployment because they were unemployed in both waves? And then person O, good news, he walked out of unemployment. So he transitioned from unemployment to employment. And the same to have person P. So 2 people successfully transitioned from unemployment to employment. And then person Q, he's the best person in terms of labor market outcome because he was employed in both waves. And then even if you look at the non-income welfare, you can see these two people, N and Q, they improved their non-income welfare because not, in the second wave of NITS 2010, they reported their own mobile phone. And then the last two concepts relate to the last few slides. The ceteris paribus condition, I think you should be quite familiar, holding other explanatory variables constant for multivariate regression. I trust you still remember that. And then finally, always remember correlation does not imply causation. So I think that's all for chapter 1. Thank you.